particular discipline of our discipline. And then we also did review articles to what has already been done in the area if you are embarking on a research. But from what I gathered from you, the college, is that you have been reviewing in a journal club, periodic journal club, you have been reviewing review articles as well as sometimes original research articles from several journals like endocrinology and also of chemical biochemistry and so on. So you might be familiar with reviewing or critical appraising journal articles in a journal club. Now, as for the original research papers, why do we read them? First, obviously, before you do your own research in the area, to know what has already been done, we do this. And then to learn research methodology in our area or in general, we might read original research articles. And then obviously, when somebody submits a manuscript for an experienced researcher, other people submit manuscript for journal or even for example conferences. And then the editor or the conference management, conference editors allocate that article to you as a peer reviewer. So you review the manuscript, not the published journal article, but the manuscript. Critically review it, obviously, in that sense. And then obviously when we ourselves write literature reviews, for example, in a thesis or your PhD dissertation or systematic review or meta-analysis for a journal article, again we read journal original research papers. Now, before moving on to critical appraisal, I will just go through what makes scientific research or a paper meritorious. This can be sort of assessed in two domains. One, in the x-axis in this graph kind of thing, you can observe the scientific rigor of the study, and the y-axis you have novelty. They are two independent things. Now, if the study has scientifically rigorous, and if it is novel, if it is new, that is the best research. That is where that lies on the top right-hand corner of the screen. Now, if you are doing a replicating study, for example, it is not novel, you want to see whether you also can replicate what has been demonstrated elsewhere for example, in a different country. Or once you buy a machine into your lab, for example, you want to replicate some findings and see whether that can be the laboratory conditions replicate the same things that has been documented by the company or the research, original researchers. Then obviously, when the scientific rigor is poor, obviously that is not science. So if the scientific rigor is poor, but it is really new, obviously that is good fiction. For example, Harry Potter, that sort of things might lie here. So, but it is not science. Okay. Now, what are the characteristics of a high impact research and a research paper arising thereof? So, high impact research is novel, obviously, as we saw in the previous slide, and they pose an important research question, scientific research question. Also, if it fulfills all these 5 criteria, it should be really good research, but mostly high impact research fulfill one or more of these criteria. The second criterion is it makes a significant conceptual advancement in the field of study. And the study designs are tight so that the scientific conclusions can be made in a very sort of a robust manner. So it uses the data analysis method that are most appropriate for the test hypothesis. You have a research hypothesis, the data analysis methods are conform to that. We will move on to the details of this later. And the other thing is the discussion. If you, most of the time when we see postgraduate research, we see the discussions are the parts that are the weakest because they are not data driven. They are not driven by what you found. They are driven by, for example, sometimes our speculation, sometimes what we thought even before we starting the research, or sometimes based on other people's research on. So it has to be data driven. Now with this, we will move on to the critical appraisal framework itself. Now this talk is based on the content that I regularly use from this particular network, what we call the Equator Network. Equator is an acronym for Enhancing the Quality and Transparency of Health Research. You have gone through some of these guidelines, for example, randomized control trials, we have consort guidelines and so on. So there are different reporting guidelines. So reporting guidelines are the ones that are required when you report a, not required, that are preferable when you write a journal article. So usually when somebody writes a journal article, they check this against these guidelines, and the journal editors strongly encourage the researchers stick to these guidelines, particularly if you publish a randomized control trial. So if you log into this network, I will share the PDF of this document at the end, not only the recording, so that you can click this and go to the networks and go through these checklists. And there's another useful resource was caspuk.net. It's a commercial company, but it does have certain checklists which are somewhat useful. And also this depends on my personal experience as an author and a review journal articles and some postgraduate research and so on. So I will be using that also. Now, one thing that you should excuse me with is that I am not a chemical pathologist. So my subject now, when you critically appraise a journal article, the first and foremost thing is you have to be a content expert. You have to know the subject. The knowledge is the first thing. So if you don't have knowledge, you can't critically review a paper, critically appraise a paper. So therefore, I will be using the papers that we have published, we have worked on. Not to say that they are the best papers, but those are the ones that I know well, right? So I will give you some examples of if you go along using those papers, and also I will perhaps switch on to some of these papers published in your journals. Without getting examples, it's very difficult to theoretically explain this, right? So if you do have any questions, please ask as we move along. Right. Now, what are the rules that apply when we critically appraise a given paper? Now, the paper is there. We have selected the paper for the journal club, for example. So one thing is, irrespective of the study design or even the study area, the field of study, there are general rules that determine the quality of any original research article. Now, here we are going to discuss only about original research articles. So there are general rules. And then there are specific rules that apply to different study types. For example, randomized control trials, there are certain different rules. Observation studies, different rules. Then I think most probably, if somebody can answer me, you might be sort of using diagnostic and prognostic studies. For example, sensitivity and specificity of a particular test and all that. Is that the case? This is a major area in, I think, in chemical pathology, if I'm not wrong. Anyways, so I will move on. Was someone answering?
Yeah, I think we do diagnostic and prognostic studies in our research as well.
Yeah, thanks. Okay, so now what I'm going to do is I'm going to go through each area. Now, some of these questions, now, we don't, for example, critically appraise introduction like separately and forget about that, and then move to the methodology and critically appraise methodology, and then forget about it, move on for the results and so on. So all these are interlinked because when the critical appraisal is a thinking process, so the thinking process goes on, it jumps back and forth as we read through the article, right? So although I have divided this into different areas, A, B, C, D, and so on, so always we need to keep the stream of thought in our mind. So this is how this goes. Now, if you start with the title and abstract, now these are largely based on, for example, equator guidelines for different trial types, right? One thing that we need is, what we want to know is the study design identified most preferably in the title or at least in the abstract? So these are two of the papers that we published some time ago. So first one is not a randomized, it's a crossover trial. We examined, I will just introduce you to the studies also because I'll be using excerpt from these studies, these papers repeatedly throughout the talk. So this was a study, a line of work that we do. We use a compound called L-theanine, which is consisted of P, an amino acid. It doesn't form proteins, but it's an amino acid. And we administer this in purified DNA to test different cognitive functions of healthy volunteers so far. So this was a double-blind, placebo-controlled crossover trial because you give a placebo today, and then after washout period, it's pharmacology, we give the active treatment after some time. So so the title says L-theanine improves neurophysiological measures of attention. Attention is one of the cognitive functions in a dose-dependent manner, a double-blind, placebo-controlled crossover study. So it describes the study design. So this was another one that we did about 10 years ago. So this study, and it was an epidemiological study, risk of road traffic accidents in patients discharged following treatment for psychotropic drug overdose. Patients get admitted with psychotropic drug overdose like quetiapine, olanzapine, benzodiazepines, and so on. And we examine how risky is that overdose because it impairs your cognitive functions. How would that affect their driving and the risk of traffic accidents in the period following discharge? So this was a self-controlled case series study. It is a modified form of cohort study. So again, the study design is given in this. So when you in a journal article, when you read a journal article, when we read the study design, we expect certain things. For example, in the first title, when we see double-blind placebo-controlled crossover study, we expect in the methodology to have that kind of randomized crossover thing and how what the placebo was and everything. So we don't really sort of walk into the methodology section blindly. It is like history taking. For example, when you take the personal history and the personal complaint and everything, we expect, okay, what am I going to expect in the clinical examination? What are the investigations that I am likely to order from this patient? It is like that. Now, this is a summary of that second paper. I will just go through this because in the abstract, it gives a summary of the design, methods, results, and conclusions. That is a must in an abstract. So I have highlighted the sections that describe these parts. I have not even included the methodology in this one. So basically, I will take you through this whole study abstract. I will read through this because it is too small. The background is use of psychotropic drugs is known to impair driving and increase the risk of road traffic accidents. They are also the most common drugs taken in overdose in hospital-treated episodes of self-poisoning within the real of birth. Most patients who take psychotropic drug overdoses are discharged within 48 hours while they still have possible subclinical drug effects. Again, this is a case in the West, unlike in Sri Lanka where the patients are kept for like a week or so. They are discharged very soon because hospital beds are very important in particularly emergency department. So the objective of this study, using this particular design, which we have given here, we aim to determine whether patients with psychotropic drug overdose are at a higher risk of a traffic accident in the period following this overdose compared to a control period of the same person that was before taking the overdose. So obviously, this is not a prospective study. We linked large databases, traffic accident database and hospital admission database, got about some 50,000 patients, and did a retrospective cohort, made a retrospective cohort. So we matched this and found how many accidents happened before overdose and how many accidents happened after overdose, and then calculate the risk ratio. So what we found was the patients are about 3.5 times higher risk compared to that control period, pre-overdose period. During the first 3 days, about twice the 2 times higher risk within the first 7 days, and about 1.6 times the risk compared to the baseline risk within the first 28 hours. That is called the extended post-discharge period. So we have given the methods and the results, and the conclusions we have certain things. I will just read this one. Self-poisoning with psychotropic drugs is associated with a markedly increased risk of a traffic accident during the first few days following discharge. So that was the conclusion, and these findings raise clinical and medical legal implications and so on. So this was our abstract for this particular thing. Now, if it is a diagnostic accuracy studies, they expect, actually any reader would expect at least one measure of accuracy to be reported in the abstract. Either the sensitivity, specificity, the predictive values, say for example, positive predictive value, or if you use receive operation characteristics, that is where the ROC curves, area under the curve. I hope at least we are sensitive, we are conversant with sensitivity and specificity in this 2x2 contingency table. For example, these are used extensively in any like microbiology research when you so okay, now those are the measures of accuracy in a diagnostic test. Now, if you look at this paper published in Journals of Clinical Biochemistry, the title was serum GP88. I don't know what that is, but some compound as a predictive biomarker for hepatocellular carcinoma in patients with viral hepatitis C after direct acting antiviral agent. So they have given direct acting antiviral agents for hepatitis C patients, and they have measured this GP88 titer before and after treatment for them. And they have also followed them up and examined what happens to this titer with time. So what they observed was the serum, I will just read the highlighted part. After antiviral treatment, the serum GP88 concentration of patients who eventually developed hepatocellular carcinoma was significantly higher than those who did not develop hepatocellular carcinoma. So in other words, what they say is high serum GP88 is associated with development of hepatocellular carcinoma in a patient who is already having hepatitis C. So likewise, they have made several comparisons. In all this comparison, if you can see, it doesn't give the predictive value as such, or predictive value or sensitivity specificity. What it gives is there is a significant difference. Perhaps they must See, if you measure GPA88 as a continuous variable, they might give the mean difference. So this is not a, so this study does not give any of these measures. So I would say in this yardstick, this is not a good abstract. Let's see why that is the case using the same paper later. Right? So it does not give anything about sensitivity, specific, predictive values or operation characteristics, which means the ROC curves help us to calculate sensitivity and specificity later on. So moving on to the introduction. Now this part I think you know when you know how to write a journal article and so on. So the introduction should give the article that you when you read in this article, the introduction should give the scientific background and explanation of rationale for doing this particular study. So most preferably, the study should have a pre-specified hypothesis. I will tell you the importance of this later. Pre-specified hypothesis based on the evidence and the rationale that we develop. And then, if it is a diagnostic study, the introduction should explicitly say the intended use and the clinical role of the index test. And then there should be specific objectives. I will give you an example. For example, this was the sort of end of the introduction of one of the studies that we did, right? The same study that I described the abstract, right? So in research, when you assess the research design, there are certain components that we need to concentrate on. So what type of research question is being asked? So there in the research question, there are several components. And if you say PICO guidelines, P refers to the patients, I refers to the independent variable, C refers to the comparator group or the comparator condition, O refers to the outcome variable. So your study design in the paper should include all these in it. The group of population with inclusion and exclusion criteria, that is under methodology section. The independent variable that you use in this particular study, the group of patients are the people who were admitted to the hospital with self-poisoning in this state, New South Wales state in Australia. So that is a patient population. And the independent variable is basically taking the psychotropic drug in overdose. The outcome of interest is traffic accidents. And we don't have a comparator group here because we are controlling with the same person's pre-overdose period. So if the person is having some psychiatric illness, which itself make the person put the person at higher risk of traffic accidents, we control for that. Because before taking the overdose, person has the psychiatric illness risk factor, but after overdose, he will have the psychiatric illness risk factor plus the overdose risk factor. So it is a part of the so-called confounding by indication. Then if there are confounding variables, those should also be included in the research question, right? So what's the study? Other thing is we have to ask, what's the study design appropriate for the research question? For this example, it is not the best design. If you can do a prospective study, collect data prospectively, then the data will be more accurate. But the problem with self-poisoning data is self-overdose, self-harm self-harm studies is you cannot predict when the person is going to do it self-harm. So these are perhaps one of the best designs that we had to go through given the situation. Now, was the study powered enough? That is a sample size calculation. Is I think very, very prominent topic when it comes to PGI and dissertations and all that. Sample size calculation. Now, this is the same paper, that GP88 concentration paper that I showed you earlier. Now they have measured in the results section, I told you. They compare the concentrations. They did not measure the accuracy or any accuracy measures, like for example, sensitivity, specificity measures. Why was that? The method section tells us the reason. So it says we measured the serum GP88 concentration by using sandwich and sandwich immunoassay from 67 healthy control subjects and 29 patients. 20 patients who did not develop hepatocellular carcinoma and 9 patients who developed hepatocellular carcinoma. Now, to do that kind of, make that kind of contingency table and do that kind of sensitivity specificity analysis, you need a much larger sample. So that is why probably they have not done that kind of analysis, which was a wise thing to do. If they have calculated that and given the results, that would be gross sort of oversimplification or the inaccurate result. So the sample sizes are very low in this case. So this could be a good sort of proof of concept or sort of introductory study for this kind of research. If this is the new area, which I don't know. If it is a new area, this could be a good study to give that some thought, create some sort of thoughts in future science. Now the other thing is did the methodology address imported potential sources of bias? I'm not going to discuss about different types of biases, but one bias is basically there is a random error. So this largely depends on the accuracy of measurements. For example, I think you will have different examples from chemical pathology area. Inaccurate measurements, how inaccurate measurements lead to random error. Now, inaccurate measurements and poor sample collection and storage will lead to systematic bias also. That is how the ward doctors always, get complaints from the laboratory. You have not stored it properly, therefore the whatever the thing hemolyzed or something like that. So systematic bias is always a bias that we transfer with our samples to the laboratories. Right. So the accuracy and precision of measurement has to be important for not only to the outcome variable, but also the exposure variable or independent variable. So in retrospective studies where the exposure has already happened and the disease also has already happened, sort of taking the history backwards or tracing the BHs and getting the exposure detail, accurate, precise exposure details is quite difficult. But it is high in RCTs because in a treatment you can either give treatment or don't give treatment or give placebo or the standard. So it is very very accurate. And outcome measures have to be accurate, and also the measuring confounding variables have to be accurate. I think you are even undergraduates are familiar with this precision and accuracy target-based diagram, 2x2 diagram. So this is where the accuracy and precision is very poor, and this is where the precision is high, but it's not on the bullseye. So the precision is good, accuracy is poor. Here the accuracy is good, but it's scattered, filtered around the target, so it is high accuracy but low precision. So this is the best high accuracy, high precision. Now, continuing on the systematic bias, we also should see in this article if there are confounding factors. So our common sense will tell us what the confounding factors are in a given disease or given exposure. So all we ought to do, for example, when we take a history from a patient in the ward, is looking for these confounding factors too. So therefore, confounding have the authors addressed the confounding factors. In the data collection stage, in the methodology, you might see they might have addressed these confounding factors by excluding people, for example, people with certain other confounding illnesses, or matching patients and the control. Or in the data analysis stage, we use complex statistical algorithms like multiple regression analysis to adjust for the variation introduced by this confounding factor. And RCTs, we eliminate systematic bias by randomization, obviously, and also blinding the participants and the experimenter. Right? I will give you an example in the next page. And also, we should see whether in RCTs, whether both groups or all arms in the RCT receive the same treatment otherwise, except the intended treatment intervention. So that will otherwise there will be systematic bias between the groups. And the other thing is, when the clinical trials are these days, these coming in big time. If you do a clinical trial, it has to be registered in the clinical trial registry. In Sri Lanka, these are registered in the Sri Lanka Clinical Trials Registry. So if you review an RCT, obviously if it is a good journal article, they will give you, okay, this was registered in a particular clinical registry. So I click the link and see at the time of registration what the outcome variables were, what the outcome variables of interest that the authors mentioned. So it should be the same outcome variables that the authors should be concentrating on in the result section also. Otherwise, you might pick the ones that are significant and try to highlight what are important. So that is why journals require for RCTs to pre-register in the clinical trial registry, and also the ethics committees in Sri Lanka expect us to register this in the clinical trial registry. And follow-up procedure is also important in RCTs and cohort studies. So in one of these papers, we have mentioned this follow-up procedure, and we could not follow them up. There was a dropout rate, but what we argue in this discussion is that we want to say that there was no systematic bias in this. So what we say is many patients, these are the patients who overdosed with organophosphate pesticides, and the control group was the people who took paracetamol in overdose. So what we say is many patients may not have received for the follow-up owing to practical inconveniences, losing interest in the study, or their families need to forget the incident of self-harm, because both arms were admitted with self-harm. None of these would have introduced a systematic bias in such reasons similarly apply to both groups. That is why what we postulated, right? So that was accepted by the journal and the reviewers in that particular instance. Now, this is an example for blinding from the same theanine study that I presented you in the first couple of slides. So this is how the blinding, in the article we report this blinding. Each L-theanine dose, which is a powder, was dissolved in 150 milliliters of distilled water stored at room temperature, whereas a placebo treatment was 150 milliliters of distilled water. Each preparation was given to the subjects in transparent drinking glass, and the subjects were made to drink the solution within 1 minute. All solutions were colorless, odorless, and tasteless, and were indistinguishable from one another. So that is the blinding of the subjects. Neither did we reveal the administered dose to the subjects. So that is the blinding of the subjects. Then one investigator who was blind to all treatment conditions conducted all tests, these EEG testing and all that. So you can see double blinding procedure described in this particular little paragraph. Now, other thing that we ask when we come to the level of data analysis, were the statistical methods appropriate for the study design? Were they adjusted for the confounders? Were they adjusted the level of significance for multiple comparisons in post-hoc analysis? So this is one example where we did the multiple comparison in on these studies, example for 3, and then what we did for the confounding factors, how we adjusted the confounding factors in label 2. So when you get the presentation, you may read through this further, since we don't have much time to elaborate on this. Now, then we come to the result, read the result section of the study. Now, usually in a good journal article, but if it is a study that consists of 2 or more groups and so on, it should contain a participant flow diagram, how many were approached and all that flow diagram. And if there is missing data, the reason should be given in the result section itself. And usually the first table in the clinical study or epidemiological study describes or tabulates the demographics and the clinical details of the participants. So this was a real study with patients that we did on the same topic. We tested what these people who were admitted with central nervous system depressant drug overdose, and also people who were admitted control drugs like paracetamol that does not affect nervous system, and tested their cognitive functions following discharge. So this says 236 eligible patients were considered. This is the first figure of that article. 236 were considered eligibility, and we excluded 27 due to these reasons, and we ended up with 209 who were eligible, and we approached 120 with the test group and 81 to the control group. And obviously, many of them did not, say 20%, 20 of them did not consent in this group, the one did not consent in the control group. We ended up with this many people. So this diagram will tell the recruitment process. In a randomized control trial, obviously, this is a must, and that is called the consort diagram. Consort diagram is a must in RCD. So if you read an RCD that consort diagram is not there, it is not a good article. Then the table, as I said, in the same study, the table describes the demographic and clinical characteristics of the study groups. For example, number and percentage of females. These are the demographics, the level of education. You can see these demographic variables are they are pertaining to the variables that we want to assess. For example, if this is a cognitive function study, the age is important demographic variable, because with age cognitive functions decline. Education is an important variable because with education, cognitive functions outcome variable increases. So these are not only demographic data, these are also confounding factors. Then there are about people with psychiatric illness, amount of drug taken and all that, whether the person co-ingested alcohol and so on. So this summarizes the demographic variables. It is not just a district of demographic variable, it gives the reader the context of confounding factors that you are envisaging to control for. Now, then the participant numbers should be given as raw data, as the numbers. For example, if it is a case control of host study, exposed and unexposed people versus those who developed outcome or not developed outcome, like in a contingency table like this. Or in a diagnostic study, test positive negative versus this is positive negative, where you can calculate the sensitivity and specificity, where the authors should calculate the sensitivity and specificity. This is an example. For example, I think they have done estrogen and progesterone receptor positivity and negativity in some kind of cancer, and then with the metastasis, incidence of metastasis, they compared. Perhaps the thing is, if the receptor positivity, their metastasis incidence is high or something. Using this, I think you already know how to calculate sensitivity, specificity, and predictive values. If not, I think you need to refer to that. Then the results also include figures. Why do authors have figures? That is to summarize. One reason is to summarize data that cannot be told in words effectively. I think somebody has switched the mic on. If you are not ready to ask a question, please can you mute it? Okay. So this is a picture of one of Chani Kalhakun's work about the study was basically she followed up patients who took different types of organophosphate pesticides in overdose. So number of hours following admission is in the x-axis. Then the fraction of patients who develop respiratory failure. So you can see this like a survival curve. So you can see some of the, like for example, this yellow line is the chlorpyrifos, one of the common. You can see people develop this and then it plateaus. So another thing like quinalphos, many people develop in the immediate admission period and then it plateaus. The third formulation, what we call profenaphos, they do not develop. Everybody will not develop respiratory failure at the same time. So in a staggered manner. In other words, what this table tells us is, if the doctor is doing the evening ward round, they will detect those who develop respiratory failure for these pesticides, but not for this one, because people will develop respiratory over a longer period of time. At night, perhaps you might get people having respiratory, nurse might be calling the doctor saying that this person has developed. So what it tells us is, if on admission, if the doctors can get the specific type of profenaphos, that the type of organophosphate compound that the person has taken using the bottle or the evidence, then you can save many people more than when you don't know what the OP is. So all OPs are not the same. Another thing that it shows is the thickness of the line is proportionate to the number of participants in the sample. So to say this in words, it takes a long time, and you say this in words, obviously you can't comprehend it clearly. But using a diagram, this is easy. So see when you read the articles how useful these diagrams are or figures. Now, when it comes to reporting main outcome measures, obviously we know that statistical significance has to be explained. But in clinical research, statistical significance alone is not important. In clinical research, if the results are statistically significant, the effect size measures are also important. So these are the p-values and 95% confidence intervals. And then there are different outcome measures for different types of studies. For RCTs, for example, number needed to treat. Cohort studies, risk ratios, risk differences. If it's case control study, the odds ratios, and so on. In diagnostic studies, as I said earlier, sensitivity, specificity, positive and negative predictive values, area under the curve, and so on. So if there are confounding factors, usually the authors report unadjusted effect sizes and effect sizes just for the confounding factor. There are some statistics involved. I think if you in a separate, I think lecture, you can sort of if you want, we can discuss about the statistics there. Now then there are tables. So that in the tables also you should have effects. This is a big table based on that epidemiological study where we did compare pre-overdose period and post-overdose period, and the number of accidents or the risk of accidents, traffic accidents that the victims face. So what we can see is there are different numbers given. So this is the effect size measure. So within the first 3 days following overdose, patients are about 3.5 times more prone to traffic accidents compared to the pre-dose period. If you go down to, for example, first 28-day period, they were only about 65% more prone to traffic accidents compared to the pre-overdose period. But if you go by the p-values, this p-value is smaller than this p-value. But clinically, smaller p-value is not what is really significant in this study, because 60% increase is a moderate increase, but 240% increase, that is 3.5 times increase, is clinically more significant, although statistically less significant. So if it is statistically significant to a certain extent, it doesn't matter anymore. If you compare two statistically significant results, what matters is effect size, right? So, and the other thing this effect has to be, it is preferable with this effect size, it's a number odds ratio, it is interpreted in terms of practical significance, in a language that the layperson can understand. For example, in the discussion section, we write a 3.54 rise in accident risk is equivalent to that of a risk associated with twice the legal limit for blood alcohol level in a person. So we know that if somebody drives after an overdose within the first 3 days, it is much worse than drug driving. So that is what I'm telling. So any policeman will understand, if they have not done crime, they will understand this particular thing. So the layperson can understand this interpretation, not the P. They will not know what the P-value is, what the odds ratio is, but they will understand what this means on the road. So then if you are doing secondary or subgroup analysis, after seeing the data, then the author should acknowledge that this is not based on a hypothesis. This is what you call a post-hoc analysis. That has to be acknowledged, right? For example, in one of these studies, we said we conduct a series of secondary analysis within the OP poison group to investigate whether the red cell cholinesterase level inhibition is related to this. Larger the inhibition, we expect worse their cognitive functions are. So that is a hypothesis, secondary hypothesis that we made, but it is not a priori hypothesis. That has to be acknowledged. So coming back to the last part, the discussion and conclusions, what we need to ask when we read the discussion and conclusion is, we should ask, do the data justify the conclusion? Are they based on significant results, or do the authors only highlight the significant results in the discussion? So there some results are significant, some are not significant. So authors want in the discussion, they don't highlight only the significant, or they do some secondary analysis and find some interesting thing, and they kind of hide the primary thing and do the highlight the secondary analysis. These type of things are called what you call, you do a lot of comparisons, and then you sort of you highlight the significant one. That is called a kind of, you go on a fishing trip, right? You just put it, and when you find a fish that is less than p-value less than 0.25, you just show it, right? Something like that. Other thing is, have the authors generalize their findings from a small sample. For example, in that GP8, whatever the biomarker study, they have not generalized. What they did was, this is what they have found. They have just stated this was the thing. So that is good practice based on sample that you got. They have not generalized. These are really good marker for biomarker for detect, predict metastasis and so on. Other thing is, we should be able to discriminate. We should be able to locate, discriminate correlation from causation. One of the like funny diagrams. Can anybody say whether this is correlation, causation, or reverse causation? So there's a cat, and the roof has buckled here, and there's a cat lying there, right? So the original post says this is correlation, not causation. So immediately a person might see this cat went on the roof, and then the roof buckled under its weight. So this type of conclusions are made in research articles also, right? If you are not very careful to look at it, that will happen. So the original posting person says this is correlation, not causation. But I would go further and say this is reverse causation. There's a causation, not that cat buckled the roof, because the roof is like this. There's a nice roof for the cat to sit on. That is why the cat is here, not here. So it is called reverse causation, right? For example, a day-to-day example is, for example, in my field, for example, people who read newspapers are likely to develop dementia. The fact it is reverse causation. If you have dementia, the newspaper doesn't make much sense to you. Let's say a newspaper, a good newspaper. Newspaper doesn't make much sense to you, so therefore you don't read newspapers. So those who are not having dementia read more newspapers, those who have dementia read less newspapers. Therefore, it's a reverse causation, not that newspaper reading will improve your cognitive function in old age. So something like that. Other thing is, have the authors acknowledged their limitations, their imprecision in measurements. For example, the laboratory techniques that they use are old, imprecise techniques. Have they acknowledged the sources of bias? Have they acknowledged the statistical uncertainty? Have they acknowledged the limitations in generalizability of the results, like that GP88, that biomarker study? Do the findings fit with the available evidence? Have they contextualized their findings with the general evidence? Or does the study add anything to new evidence in my field? That is the other thing as a clinician that we need to understand. And interpretation of the data in terms of clinical in contrast to statistical is the same thing that I mentioned about that study. A 3.54 rise in accident risk in that study is equivalent to that associated with a blood alcohol level of 0.09, which is nearly double the legal limit for driving in New South Wales, Australia. Even in Sri Lanka, it is 0.08, so it's still a amount of drug driving in Sri Lanka. This sort of thing. So in fact, as a result, what they did after this study was, the clinicians the clinicians can temporarily withhold the licenses of patients. So they strongly advise people not to drive for 3 days. The person is a commercial vehicle driver. The clinicians in the New South Wales, after this, they advise there's a guideline that they advise people, if you are a commercial vehicle driver, you should not drive for 28 days following orders. If you are a personal vehicle driver, you are not carrying the burden of lives of other people with you. So after 7 days or so, you are okay to drive. Now, finally, as a clinician, we want to know what can I get from the study into my clinical practice. Again, we look at this critical. So what can we ask? What are the questions that we can ask? Can the findings be applied to the populations where the study was done? For example, one of the notorious cases was they have tested HIV drugs using RCTs in Africa, but at the end, obviously, none of those rural impoverished communities can afford that. So that is a major problem. Then the diagnostic studies, what is the intended use and clinical role of the index test, which we also ask in the study design. RCT, if it asks you what is the risk benefit ratio in this particular drug if I start giving this? Or would the intervention provide greater value to the people in my care than any of the existing interventions? So journal clubs conducted by clinicians, I think one of the main goals is for them to answer these questions. And the other thing is, once you go to the other data in the journal article, you should see whether there are any conflict of interest of the authors. Usually they are asked to, journal editors ask them to declare them explicitly, affiliations of the authors, funding sources like, for example, pharmaceutical companies and so on, and the royalties and the consultancies they have given to the pharmaceutical companies. So that is the case. But I don't think not many Sri Lankan journals declare this, but if you take a good international journal, they will. Now, there are a few extra tips if you go through research published online. Now, you can look for, if you need further information, most of these journal articles now have supplemental, online only supplemental data. So if you have doubt, you can go through supplemental. This is one of the supplemental data links in one of our papers. So they say supplemental data is published in the Taylor and Francisco. Supplemental data for this article can be accessed here. This is a footnote of the PDF document. If you click here, you can access supplemental data. And also, if you are really into this particular research study, you can also contact the author for further information. So all the authors put their name, affiliation, and the email address, the corresponding author in the journal article. And nowadays, there's a trend that you have to publish research highlights, graphical or video abstract with the journal article in their website. The idea here is the journal is it's a business, right? So journal editors and the publishers want to attract attention of the scientist, immediate attention of the scientist to this article. So that is why these highlights, graphical and video abstracts are there. So there are many of them are not peer reviewed. So it is just to lure the readers to read the full article, not to see this and then give a lot of conclusions, make legal decisions. So do not go by them only without reading the article. This is just kind of an advertisement for the full article. It is not the full article itself. So therefore, be very careful in interpreting this. I think this is very common in social networks. They see some research highlight and then they try to argue back and forth based on the highlight without reading the methodology of appraising the article. Now, finally, how to improve our critical appraisal skills. These are my tips, in fact. So go through critical appraisal reporting guidelines that I showed you, equator network guidelines, for example. And as you are already having, have journal clubs that discuss particular original research articles, not reviews. And if you do see major flaws in an article, which is considered good in a good journal, write to scientific criticism of the article as a letter to the editor. The editors accept that and they write it. Then the authors get a chance to put their sort of answer to that. So this goes back and forth 2 times, and the editor is the person who is mediating. Other thing is, one day if you get invited to review research abstract or conference abstracts or review articles, spend time on the article and accept that. The thing is, you should spend time on the article. Usually, if you get a complete full-text journal article, you should spend at least 5 to 8 hours with the article to give a good review. And when a reviewer gives its comments, it is given in full sentences referring to specific points of the article. This is one of the weakest points in Sri Lanka. Our reviewers in Sri Lanka think that somebody sends an article, he's an examiner for a student or something. So they write very callous remarks. I think you may have post-graduate dissertation, you may have seen that even ethics applications, they write a couple of words without full sentence and put a question mark or something and say, we can't understand what the person is saying. That is very rude to do that. So I will just show you one of the articles that we submitted this OP paper. It was sent to the editor. I'm just writing my response to the editor here. So what is shown in italics, although you might not be able to read it, this is the comment of the reviewer. It is written in full sentences in English very nicely, and it is that explains what it is. Right? The paper tries to answer this question. In full sentence, it is there. Once you get the PDF, just read through this. So that is what is important. So that proper way of communicating is very important. In full sentences, reviewers and experts are not exempted from writing full sentences. So finally, now we learned about the critical appraisal as a kind of a bit kind of antagonizing if you look at the whole thing. but that is the name of the game. So the physicist Richard Feynman, right? He was a theoretical physicist. What he says, he points this whole thing into this particular quote, right? I quote: "Religion is a culture of faith. Science is a culture of doubt." So that is what obviously I am not using to compare science and religion. What it says is, if you want to embed yourself or ground yourself in a particular culture, you have to sort of embrace the virtues of that culture. So if you want to embrace religious culture, you have to have faith. If you want to embrace a scientific culture, you should be doubtful and you should be critical. If you embrace a scientific culture out of faith, that will destroy you and science both. So that is what I want to tell you as a parting remark, so to speak. So that is the spirit. That is what critical appraisal is. So I'm happy to answer any questions in the presentation. So there is something on the chat. Dulan, did you want to take over and moderate this?
Yes, Tharaka, thank you very much. I think within the short time, you managed to touch almost all the areas, basically. And there is in the chat, there is a question.
Yes.
The question is, yeah.
So
Can you see?
I didn't get what effect size is. Could you please explain again? Okay, I will explain this. Now, effect size is, let's say, okay, I will give the simplest thing. Now, effect size is, for example, let's say what the difference is. Let's say you measure the weight of two groups of people, right? Two groups of people who have unhealthy diets or healthy dietary habits. Now there's a difference in body weight, mean body weight or something. Mean BMI, let's say mean BMI difference is 3 units, kilograms per square meter, 3 units. But the point is, we don't know, that is just the difference. We can say, okay, the difference is the effect. But the point is, we also want to know this 3 difference. What, let's say 3 kilogram difference, there's a 3 kilogram difference. Whether this 3 kilogram difference is, so effect size is directly proportionate to the difference or the ratio between the two groups, but it is inversely proportionate to the distribution. I will give a very sort of funny and sort of silly example. If there's a mean difference of body weight of 10 kilograms in two groups of humans, do you think it is significant? Effect size, do you think it is a significant effect size? Can the person who answered the question, wrote the question, can you answer? In human, there are two groups of humans, let's say people, office workers and manual laborers. Body weight is difference is about 10 kilograms. Do you think it is? Do you feel that it is, effect size is significant?
No, sir.
10 kilograms is not different. Let's say, okay, let's say I will say 30 kilograms. Is it significant? Do you think it is significant? Likely significant effect size. 30 kilogram difference, 60 and 90 or so. Okay, now if you compare two groups of elephants, African elephants and Sri Lankan elephants, do you think the 30 kilogram difference is significant?
No.
Not really, right? That is because the difference is there, but there's a big distribution. So elephants, the weight ranges in tons, for example, hundreds of kilograms. So therefore, the distribution of whatever the variable also matters. So the larger the distribution, effect size is smaller. Larger the difference, effect size is larger. So it's a ratio of the distribution which is measured in standard deviation in statistics, and the group difference is measured in mean difference. So it is mean difference divided by the standard deviation. So in a ratio, the effect size is, for example, in my example, odds ratio is the effect size in a ratio. Because in a ratio, if it is 1, so 1 to 1, there's no difference. If the ratio one group is about, say, if the particular incidence of cancer in one group is, for example, 100 in 1,000, and the other group it is 50 in 1,000, so the ratio is 2. So that is the effect size. Because it's a did you get my answer for that?
Yes,
effect
sir.
size.
Thank you very much.
Yes, sir, in fact, I will email effect size calculation on one of the papers, the seminal papers. Share that material with Dr. Tulani so that you can share it. Any more questions?
Any other questions from the audience? If you have any clarification, now you can ask. Tharaka, is there any guide for the abstract, like the critical appraisal of the abstract, apart from the original?
Equator network gives critical appraisal of an abstract. The couple of fields are there. It should contain the things that I mentioned: the objective, the study design, the methods, and the analysis technique. And this, there is, I don't think there is a. There should be. I will. No, I have not come across that. One thing is obviously abstract is not enough to be critical appraisal. For example, just an abstract is, if you ask me what is the smallest functional unit of science, it is a full text research article, not an abstract. Because abstract does not tell us whether you cannot reproduce what the person did using an abstract. Therefore, I expect, I initiate that there aren't many guidelines to what an abstract is, how to review an abstract. Because the place of abstract in science is, one thing is, before you publish this, you present it to a group of peers in a conference, and so that the peers will, because not that is not be only the abstract, but the presentation that you make, or let's say 10 issues or the free paper that you present. So with the abstract and the free paper things that you present, the peers will comment on your findings and your research study, so that you can improve on the study. That is, in an interim analysis, you can provide an abstract so that you get, that's room for improvement. That is first role of abstract. The second role of the abstract is when you go and present this abstract in conferences, other people know that this person is working on this area or has worked on this area. Therefore, we can network, we can collaborate with him, and we can make a bigger study. For example, in that study where they had the Japanese Ishida study where they had hepatocellular carcinoma and hepatitis C, and that was a biomarker, they have presented that series. So if that is a new thing, after reading that abstract, people might, if they present that abstract, or there is a not good paper perhaps, other people will around the world will get that. So they will get most, in a multi-center study, they will get more people with hepatitis C and hepatocellular carcinoma, which is a prospective study. So they'll have multi-center studies in all over the world, in 20 centers, for example, Europe and everywhere. They'll have a larger cohort, so that they will be able to calculate the sensitivity, specificity, all those measures in a larger sample. So that is the role of the abstract. So therefore, usually, well, to tell you the truth, like most of the abstract, almost 90% of the abstracts are accepted in conferences, aren't they? Right? So
Yes.
they are not rejected. So they will assess them very critically. They're like really bad, obviously you reject it, but then you don't need any criteria. You know that it's bad. Right? So that is where it stands. It's a long answer, but
Yeah.
that is the realistic answer.
Any other questions?
If I come across something, I will pick you the abstract listing guidelines. Yeah.
Any other questions? Okay, in the absence of questions, I invite Dr. Madhuri Vidyanatharana, Secretary from the College of Chemical Pathologists, for the vote of thanks.
Now we have come to the end of the webinar. It is my pleasant duty to thank those who contributed to make this webinar a success. Firstly, I would like to thank Professor Tharaka Dassanayake for delivering that excellent presentation on critical appraisal of a journal article. It was indeed a very insightful and interesting presentation. It will definitely be a good initiative to incorporate critical appraisal in our future journal club activities. A token of appreciation will be handed to you in due course by the College of Chemical Pathologists of Sri Lanka. We hope that we can expect your involvement in our activities of the college in future as well. I also would like to thank Dr. Dulani Jayawardena, President of the College of Chemical Pathologists of Sri Lanka, for the leadership given to make this webinar a success. Also, I would like to thank our participants joining with us from all over the country. Without your presence, this wouldn't have been a success. Hope to see you all again soon in a session like this. Thank you.
Thanks, everyone. Thanks for listening.
Okay. Thank you.